max for 2 hours. So let's start with the question 1. Question 1 is telling us which of the following statements regarding vector and scalar is incorrect. Okay, so before we get to know the answer, we need to know what is a scalar and what is a vector. So a vector is basically a physical quantity that has both magnitude and direction, whereas a scalar is just a physical quantity with only magnitude. Okay, let's look at the options provided. So option A, they're telling us a vector and a scalar both have magnitudes. That is correct. Remember, we're looking for the incorrect. And then B, a vector and a scalar both have physical quantities, which is also correct. Then C, a vector and a scalar both have direction. So it's only the vector that has direction. Scalar doesn't. So this statement is wrong. Vector has direction, scalar does not have direction. This is also correct. So C will be the best option. And then 1.2, a graph shows the relationship between position and time of a car that is moving in a straight line. So one can conclude from the graph that the velocity of the car increases with time. Well, the increase with time would be the position, because as the position increases, even the time is also increasing. But remember, the gradient of this graph. Okay, so if we find the change in position over the change in time, that will give us the velocity. So in this case, we expect the velocity to be constant. Okay, so velocity remains constant with time, which is B, since the gradient of a straight line is always the same. Then 1.3, a motorbike that's moving at a speed of V has kinetic energy, okay, which is E. If the speed of the motorbike increases to 4V, the kinetic energy will be, so from the formula of kinetic energy, EK is a half mv squared. That will be a half multiplied by m multiplied by 4, I'll say 4v, but squared. I simplify this, I'll have a half m times 16v squared. When we try to simplify, do we need to simplify that? Not really, because I'm seeing a 16, the space would be like 16 multiplied by a half mv squared. So if EK or E was a half mv squared, which is this, so which means our overall energy is going to be 16 times. That is 1.3, and the answer is 16E. 1.4, consider the following statements concerning the ultraviolet radiation. Which of the following? No, it has a lower frequency than blue light. Okay, it has a longer wavelength than the gamma rays. It is radiated from the sun and may be harmful to humans. So lower frequency than blue light, no. Longer wavelength, that is true. Because yes, it has longer wavelength than the gamma rays. And then 3 is radiated from the sun, which is also true. So 2 and 3. Then 1.5, if we consider the diagram of two pulses A and B, I don't know, I found an issue with this question, whereby 1, we have the amplitude of A, but we don't have the amplitude of B. Let's read the question, maybe it will make sense. So if we have the following pulses, A and B as shown below, the amplitude is 25. In this case, we don't know the amplitude. Okay, when two pulses in the diagram overlap, okay, when they overlap at point X, so which means this A is moving to the right, this one is moving to the left. They're telling us that the resultant amplitude is a 40. Okay. The type of interference and the amplitude is, the type of interference, and the amplitude is. Now, since both of them are just in the same kind of direction, both of them are traps, so we expect the resultant wave or the resultant pulse to increase, okay? In other words, it should be bigger, which means it's going to be a constructive interference, okay? But because if this is a 25 with this amplitude and it's the biggest pulse, this is a shorter pulse, which is B. With a shorter, I'm having 15 and 15. I would have gone for A. I would have gone for A, which is like the destructive, since the directions are different. I mean, I'm moving in opposite directions. Okay, the arrows indicate that the directions are opposite. I'm going with option A. Can't be constructive, but doesn't make sense though, because when I say 15 and that's a 25, then given the 40, which means I'll have to go with B because of this 40. I'll go with B because they told me the resultant. So it means a constructive, but with that. All right, then 1.6, two identical spheres A and B are placed on insulated strands and they are carrying charges +2 microcoulombs and +6 microcoulomb respectively, okay? So when the spheres are brought into contact, dash electrons are transferred from which sphere to which sphere? Okay, so one thing we need to know is that when the two get into contact, we shall have a 2 plus 6, we get 8, and then we divide by 2, which means each sphere will walk away with a +4 microcoulombs. Okay, so if that is true, how about if we calculate the number of electrons that would be transferred from N is equal to Q over E? So since this is a 4 microcoulomb, and we subtract the 2 microcoulombs, so which means there was a transfer of +2. Okay, I'll say 2 times 10 to the -6. I'm dividing it with a charge which is 1,6 times 10. Is it -11 or -19? Should be -19. Should be -19, yes, -6, -1,6 times 10 to the -19. Okay, so we're saying -19, not 11. So when I divide that, -6 over 1,6 times 10 to the -19. That's giving me 125 and a whole lot of numbers, zeros. So 1, 2, why should I look at that? I only have 1,25, this and that. I have option A and option D. Then I need to know, where will the electrons be moving from? Is it A to B or B to A? Okay, so in this case, this +6 is more positive than the +2, which means the electrons will be transferring from A up to B so that they lower this positivity to just a 4. So I'll go with A. Then 1.7, 2 light bulbs, P and Q connected in parallel. You can see that. the resistance of P is twice the resistance of Q. If this is just 1 ohm, this is going to be like 2 ohms. If this is a 2, that will be a 4. Voltmeters V1 and V2 are connected across each. Which of the following statements will give the correct relationship of the voltmeter readings? So remember, the two are connected in parallel. As long as resistors are connected in parallel, the voltage has to be the same. So V1 must be the same as V2. That is option A. Okay, so that was question number 1. Question number 2, we have a brother and a sister that walk home from school, okay? And then after walking 600 meters eastward, the brother realizes that he has left a book at school. He then returns before he walks back to their house again, but the sister continues walking another 900. Okay, she arrives home 40 minutes after leaving school. Assume that everything is in straight line and in an eastward direction. Define what speed is. So we could say that speed is just the rate of change. Speed, the rate of change in distance, rate of change of distance, because velocity will be displacement. The rate of change of distance or in distance, whereby we know that speed is distance divided by time. Or you could give it that way. Is the distance traveled over the time taken. Okay, then determine the distance that is covered by the girl from school to her home. So we know that she walked 600 before the sense got to the brother, that he had left some books at school. So that will be a 600 plus the 900 extra. Okay, so 600 plus 900, we are getting 1.5 meters. Okay. Then 2.3, they want us to draw. Okay, use a vector scale diagram and represent the motion of the boy as a resultant from the time he realized he has left the book at school up until he reached home again. So what I can see is that, remember home is east, né? From the drawing. School is on the left or in west direction. So if this is school, okay, I'll call this school, and then I'll call this home. Remember, we have to, okay, so they had walked 600. So I'll say from there to the left. And then I'll have to draw 6 centimeters, since 1 centimeter is representing 100 meters. Then from there, when we look at the girl's distance that was traveled, the girl traveled 6, and then she traveled again 900, which was 1.5. Then from this point, I'll just have to draw another line, which represents 15 centimeters. What is the question asking for? They're asking for the resultant displacement also. So the resultant is the point, let's say, from where the boy started the movement up to where he ended. So this is our resultant. I'll just indicate it like that. So this is 15 minus 6, which is 9 centimeters or 900 meters. Can do this, so I can even represent it as the meters. Okay, so this is our resultant. All right, so this resultant must be 9 centimeters, just the balance of that. Then 2.4, how long did it take the boy to reach home? From the time they both left school, if the average speed of the boy is this. Now, what we need to know about the boy is that, 1, he walked from school for 600, and then he went back again, and then he moved another 1.5, which means that for me to get, what do they want? How long? They are looking for time. So speed is distance divided by the time. which means that time is going to be given as distance divided by the speed. So what distance do we say? This guy is moving 600 and then another 600, which is 1.4. 1.2, sorry, 600 plus another 600, and then plus the 1.5. So 1.2 plus 1.5, which is 2.7. So this guy travels 2,700 meters. The speed is 0.82 meters per second. Okay. So if I try to divide this from my calculator, saying 2.7, but they said we must give the answer in what? In seconds, which is going to be kind of a big answer. Okay, so it's 2.7 divided by 0.82. 2.7 divided by 0.82. I'm getting a 3292.68 seconds. Okay, so that is what I'm having for 2.4. Then question number 3. Question number 3. A car initially at rest moves with a constant acceleration of 2 meters per second squared. Okay. Then define the term acceleration. So acceleration is just the rate of change of displacement. Okay. Rate of change. Did I say displacement? No, it's velocity, sorry. Rate of change of velocity. It's velocity that is rate of change of displacement. So rate of change of velocity is the acceleration. Then they want us to calculate the magnitude of the velocity after 10 seconds. So we can use the VF is equal to VI plus the A delta T. Okay. So we need the VF. Our initial was rest, which means it's a 0. Plus the acceleration is 2, the time is 10. So that's going to be 20 meters per second. Okay. Then 0.2, if there is a plane that is having some unknown velocity V. Okay. And then after traveling a distance of 3.5 meters while decelerating, so which means this is a negative acceleration, it halves its velocity, or it halves its initial velocity. Calculate the initial velocity of the plane. So we don't have time, we only have velocities and the displacement. Okay, so V initial is V. V final is a half V. We have the displacement, I'll call it change in X, which is 3.5. So which means I could use the V final squared is equal to V initial squared plus 2A delta X. Okay, I could use this. Then my V final is going to be a half V squared is equal to my initial, which is just a V, plus 2, but the acceleration is negative. I will say -5, and then I'm having a 3.5 there. So a half V squared, that's gonna give me like really, that's gonna give me 1/4 V squared. Then I'll move this V squared that side, minus V squared is equal to negative, I'll say 35,000. Okay. Then if that is true, I need to get rid of, okay, when I subtract that, that's going to be -3/4. V squared is equal to -35,000. So divide both sides by 3/4. So which means my V squared is going to be, that's 35,000 I'm dividing by 3 over 4, which is 4, 6, 6. How many sixes? There are 4 sixes, comma 6, 7. And then I find the square root. Okay, so square root of my answer, I'm getting 216,02. What was that? Meters per second. So 216,02 meters per second. All right, then 3.3. Velocity versus time graph for a racing car initially moving east is shown here. Okay, starts from A to B, then it's constant, then it goes that side. Determine the speed of the car at t is equal to 10 seconds. So t10, we shall assume it's somewhere here. So you can see that the velocity is still constant, which is 40. So I'll say that is 40 meters per second. Then 3.3.2, can we describe the velocity? Looking at the magnitude and the direction of the car between C and D. Okay, so one thing we can say, between C and D, the velocity moves or decreases from 40 to a 0, because at D, the velocity is a 0. Okay, and in which direction is that gonna be? So initially, the car is moving east. Initially, I moved east. So from A to B, that would be the east. And then C to D, will that be west? Does that make sense? Initially moving east, because now this velocity is dropping down, which means it's the deceleration of, no, it's okay, which means it's only D to E, sorry, it's D to E, where it will be now a west, since it's below that. So, but C to D is still east. Okay, so we're going to say that velocity decreases. Velocity decreases from 40 meters per second to 0 meters per second. We can say east. Then 3.3.3, support your answer in question 3.3.2 above by calculating the acceleration without the use of equations. So what we need to know with this is, it's not making sense, guys. 3.3.2. I feel like this is gonna be a west direction. I'm gonna take west because it's moving backwards. Okay, then support your answer, because if we are to support our answer, our acceleration here must give us a negative, which means it's just in the opposite direction. Or slightly slowing down, who knows? I don't know. Okay, we know that the change in velocity over the change in time. So if I use this 40 minus that, so which is 40 minus 0, no, it's the other way around, the final first. So VF over VI over the change in time. So which means that's a 0 minus a 40 over 25 minus 20. So it's negative 40 over positive 5, which must give us negative 8 meters per second squared. The direction, since it's negative, is gonna be west. Let me just make this east. Since the acceleration is in the opposite, the velocity will be in the east. Okay, then 3.3.4, calculate the displacement of the car from A to C. So when they ask for the displacement, they are literally asking for the area that is under the graph. Okay, area under this graph. So it's your choice how you want to do it. Okay, so I can start by looking at the, what am I looking at? I can call this A. or I can call this BO1 and 2. So that this is a trapezium, and then this is a rectangle. And then I can find that area. So when I start with the rectangle, this length is 20 minus 5, which is a 15. And then this is going to be a 40. So it's going to be, remember they said what? A to C, nothing more. So that's going to be a 15, but will it make sense? Yes. It's going to be a 15 times a 40. Plus, then I look at this A, B, and the 5, né? Which is a trapezium. So with this trapezium, I'll have my H as a 5, my A as a 30, then my B as a 40. That's going to be a half multiplied by the 5 into 30 plus 40. You can even break this down if you so wish, so that you make it a triangle and some sort of a small rectangle. So punching this into the calculator, I'm getting 775 meters. So that is my displacement. That becomes our displacement. Question number 4. Do we need direction here? It will be east, the original direction. Question 4, there's a toy car. There is a toy car that is 2 kilograms moving past point A, which is 25 meters above the ground at this speed. The path ABC is frictionless. Can we state the law of conservation of mechanical energy? So we know that the total mechanical energy, we can say in an isolated system, the total mechanical energy is conserved. The word conserved simply means remains the same, remains constant. Okay, then 4.2. They want us to calculate the kinetic energy and the potential energy at A. So we know that at A, this toy car is going to have what we call mechanical energy. It's going to have the EP and then the EK. They want the sum, which is the addition. So we know that EP is going to be mgh. EK is given as a half mv squared. So the mass of the car is 2, the G is 9.8, the height is 25. Then that is a half times 2, the velocity is 12 squared. Okay, if we punch that into our calculator, I'm getting 634 joules. 634 joules. So which means for 4.2, we have 634 joules. Then 4.3, determine the mechanical energy at B. Mechanical energy. Since 4.1 told us that the total mechanical energy is conserved, which means even at B, we're going to have the same 634 joules. And as much as at point B, it's only going to be the Emax, kinetic energy maximum. Then 4.4, they want us to get the toy car. They're telling us the toy car comes to rest at point C. Determine the height. So if the toy car is coming to rest, which means the velocity at C is a 0. Okay. And we're only going to have what we call the EP max, the maximum kinetic energy. So we're going to say that at C, we are having EP plus EK, which is equal to the total energy. Just write it that way. This is going to be mgh. This is a half mv squared is equal to our total energy, which is 634 joules. The mass is 2, 9.8 times h, plus that's a half, the mass is 2, but our velocity is 0, must give us 634. Okay. When I look at my left, I'm having 19.6 h. must give me 634. Then I'll divide both sides by 19,6. So 634 divided by 19,6, I'm getting 32,35 meters. So that is the highest point H of the journey. Okay, so that is question number 4. Question number 5, waves are telling us that figure below shows transverse wave motion. The period of the wave is 0,2. Okay, define the term transverse wave. So we know that a transverse wave is just a type of wave in which the disturbance is perpendicular to the direction of motion. Okay, we're saying transverse wave. Transverse wave is a type of wave in which the disturbance or the particles, the disturbance in the medium is perpendicular to the direction of the wave. Something like that, as long as we see the word perpendicular, okay? Disturbance, particles, perpendicular. So that's how it has. Then they want us to determine the frequency, but remember they gave us what we call the period. So we know that period, which is T, is given as 1 over F, which means F is gonna be 1 over T. So I'm going to say that my frequency is 1 over T, which is 1 over 0,2. That is going to give me 5 hertz, okay? Then they want us to find the speed if the distance D is 3 meters. If the distance D is 3 meters. So we know that V is equal to F lambda, okay? But we need to know how many waves are in the distance D. Okay, that should be our first question. So this is going to be from this point up to that point. Will it make sense? No, it doesn't make sense. It's from here up to here. How many full waves are there? So from this top up to the top. So it's basically 1.5 waves within this. That's what I'm getting. 1.5 waves. So what I'm going to do, since now my wavelength is gonna be 3 over 2, so that's going to be the frequency we got, 5 multiplied by the 3 over 2. And that gives me 7,5 meters per second. It's basically 1.5 waves. Much as it looks like 2, but it's not. Because I'll look at this and this as 1. Okay. There are 2 full waves here. We have 2 full waves. Because if this must end here, that is 1 full wave. And then from here up to here, these are 2 full waves. So if the distance is 3, which means that 1 wave is going to be 3 over 2. Yeah, which makes sense. Then 5.1.3, which one? Just write down one pair of points that are in phase. So we can say that A and D are in phase, okay? But also B and F, just one. I can say B and F or A and D. Those ones are in phase. Then 5.1.4, they want us to redraw. They want us to redraw. So how do we redraw this? On the same sketch using dotted lines to draw a wave motion with half of the frequency and half of the amplitude, and we must indicate the amplitude of the original wave. So what this is going to look like is this point will be somewhere here. Since A is almost like by half, then I'll have, will it make sense though? I don't know. I don't know. We can have something like that. Up to somewhere there. So we're saying this maximum displacement, since it's we say the original, which is 15. I don't know, something of that nature. Then 5.2, SIP and Sandile do an investigation on sound propagation. Okay. And then one is holding the drum 10 meters from the wall, while Sandile is standing some distance holding the detector in the hands. When SIPO hits the drum once, the sound detector receives 2 sounds. Okay, so if the speed of sound is 343, 5.2.1, explain why the detector receives 2 sounds. So one, we know that the first sound should be the sound that is directly from the drum. Okay, so we have sound from the drum after SIPO struck the drum. And then the second sound will be the reflected sound. Reflected sound from the wall, because we know that when sound travels, it takes some bit of time before it could be detected. But as long as the detector is some distance away from the wall. Then 5.2.2, the second sound reaches the detector after 0.15 seconds. After SIPO hits the drum, calculate the distance between SIPO and Sandile. So if this is our X, they want us to get the X. Remember, we're saying the second sound is the reflected sound. Okay. So what we need to know is that the sound is going to move, and it's also going to move before it moves that side. So that is more like it travels 20 meters plus the additional, which is X. I don't know if that makes sense. Let's see. Speed is equal to distance over time. Okay. So if I look at the distance that was traveled, it will be the speed times the time. The speed of sound, they told me, is 343. The time it took was 0.15. So when I put this into my calculator, 343 times 0.15, what do you give us? We are getting just a small number, not so big. That is 49.95 meters. Okay. So if it is 49.95, and remember we say the sound moved from the drum to the wall, and then from the wall to that point. So I need to subtract this distance first. So that is minus 20. So which means I have 29.95 meters. So that must be the distance between Sandile and SIPO. 29, that much. Okay, so that is how I would have calculated 5.2. Question number 6. Question number 6, consider a laser pointer and a cell phone as shown within this diagram. Okay. State the type of electromagnetic radiation that is emitted by the laser. What kind of radiation is this? We could say it's red light. Does that make sense? Okay. Or someone can even say monochromatic, since it's just one type of light from a laser. Then from the cell phone, so these are normally what we call the radio waves, or even the microwaves, since they are under the same category. And 6.2, they're telling us electromagnetic radiation has a wave particle duality. What does this mean? So it simply means that it possesses, okay, it possesses both the wave-like characteristics. Okay, it possesses the wave-like characteristics. So that is what that means, okay? Wave-like characteristics, and what else? Because wave particle, which means even the particle. So wave-like, let me just add it here. Let me just say wave and particle characteristics. Okay, then 6.3, a cell phone screen emits the blue light photons with a wavelength of 450 nanometers. Calculate the energy of the blue light. So we know that from this formula, E is equal to HF. We know that V is equal to F lambda. So we need to make F the subject so that it is, let me use C in this case. It's gonna be C over lambda. So which means HC over lambda. We know that H is Planck's constant and the rest. So H is 6, what did I put here? And 6,63 times 10 to the negative 34. The speed of light is obviously 3 times 10 to the 8 from the formula page or from the information page. Then we are dividing this by the lambda, the wavelength, which is 450 times 10 to the negative 9. When I punch this into the calculator, I'm getting 4,42 times 10 to the negative 19 joules. That is question number 6. 7. They want us to distinguish between a neutral object and a charged object. So one thing we know is that a neutral object is one with equal amounts of positive and negative charges. Or okay, neutral object is one with, I'll say, equal amounts of protons. It's fine. I'll say, and electrons, which means has the same positive and negatives. Okay, then a charged object. A charged object is one that has an excess. Okay, this has an excess of either protons or electrons or protons. So someone can say unbalanced number or something of the sort. Okay, so a sphere is containing, a sphere carries 2 nanocoulomb of positive charge. Can we determine the number of electrons in deficit? Okay, we know that N must be Q over E. Okay, this is gonna be 2 times 10 to the negative 9. We're dividing it by 1,6 times 10 to the negative 19. So we saw some kind of scenario like this before in the multiple choice. So this is going to be 1,25 times 10 to the 10. So these are the number of electrons that are shorting. Then 7.2.2, if the net charge on the sphere is this, what is the total negative charge in nanocoulomb on the sphere? Okay, so it's 2 marks. If the net charge is -2, what is the total negative charge? So initially it was, why don't I say 6 minus 2? So that I have a -8 nanocoulomb. Yeah, because this is the final, and then the initial is 2. So -6 minus 2, we get that. Okay, question 8. In the circuit diagram below, the reading of the voltmeter V1 is 18, okay? And then the reading on V3 is 6. Where is V3? Do we have a V3 here? V1, I'm saying a V, is this a 3? Doesn't look clear then, if that is the case. I think V1, A1. No, it's okay. I'll take this to be a V3. Okay, I'll take it to be a V3. No, actually, it's a V3 since there is a 6 there. Okay, then they want us to give one word of the following description: the potential difference across a battery when no current is flowing. So that potential difference is what we call the EMF of the battery. Yeah? Then calculate the following: the total resistance of the circuit. Now, when you look at this circuit, we have resistors that are in parallel and there is an isolated resistor. So I'll say that when I look at the parallel combination, okay, I have just 2 resistors. I will use the quick way that talks about the product over the sum. Okay, multiply the 2, that is 6 times 3 over 6 plus 3. Okay, that's giving me 18 over 9, which is 2 ohms. So which means the 2 parallel resistors will give me a total of 2 ohms. But then this 2 ohms is going to be in series with the 4 ohms. So with the series, I just add. So 2 ohms plus the 4 ohms, that will give me 6 ohms. That is what I have, okay? So you can still go that long way of 1 over R1 plus 1 over R2 is still going to lead you to the 2 ohms. And then you add the 4, get your 6 ohms. Okay, then 8.2.2, the reading on V2. V2 is here. So now if this is 6 volts, and remember this is in series with the 4 ohm, and if we have any combination that is series, the voltage is going to be split up. So if this is 6 volts, we just subtract from the total. So it's going to be like 18 minus 6, and then we get 12 volts. Then they want the reading on A2. Okay, A2. So A2 will be asking us to get the current. Oh, if A1 is 3, okay. So which means we have 3 amps that are entering this parallel combination. But I don't know, do we need that? They want us to use just ratios. How do we use ratios to do that if we are not using calculations? Now let me start by using the calculations so that we can see. We know the voltage across is going to be 6. Okay, so from V is equal to IR, which means it's going to be 6 over 6, which is 1 amp. Okay, just 1 amp is going to go there. And then in this case, we're going to have 2 amps. So that the total is still 3, which makes sense because the lower the resistance, the more the current that flows. Okay, so I'm going to do this. Okay, I'll say if I have a ratio of 6:3, when I try to divide both sides by 3 and by 3, this is going to give me 2:1. Does that make sense? No, it's the other way around. Because current and resistance are inversely proportional. So which means it's gonna be 1:2. Yeah, I don't know. Those should be the ratios. Then the amount of charge that flows in A1. Where is A1? A1 is the current, which is 3 amps. Okay, and we know that charge is Q given as IT. Okay, Q is equal to IT. We're looking for Q. So the current is 3 multiplied by the 2 minutes. 2 minutes need to be changed to seconds, which means we multiply by 60. Okay, then 3 times that, I'm getting 360 coulombs. All right, guys, so that is what you guys had to do, okay? In all, we can say it was a fair paper. Okay, greetings, all the best in your paper too. Let's meet afterwards. Bye-bye. Hello, welcome to this episode where we shall be looking at the grade 10 physical sciences paper 1 suggested memorandum. Okay, so the question was 100 marks for 2 hours. So let's start with the question 1. Question 1 is telling us which of the following statements regarding vector and scalar is incorrect. Okay, so before we get to know the answer, we need to know what is a scalar and what is a vector. So a vector is basically a physical quantity that has both magnitude and direction, whereas a scalar is just a physical quantity with only magnitude. Okay, let's look at the options provided. So option A, they're telling us a vector and a scalar both have magnitudes. That is correct. Remember, we're looking for the incorrect. And then B, a vector and a scalar both have physical quantities, which is also correct. Then C, a vector and a scalar both have direction. So it's only the vector that has direction. Scalar doesn't. So this statement is wrong. Vector has direction, scalar does not have direction. This is also correct. So C will be the best option. And then 1.2, a graph shows the relationship between position and time of a car that is moving in a straight line. So one can conclude from the graph that the velocity of the car increases with time. Well, the increase with time would be the position, because as the position increases, even the time is also increasing. But remember, the gradient of this graph. Okay, so if we find the change in position over the change in time, that will give us the velocity. So in this case, we expect the velocity to be constant. Okay, so velocity remains constant with time, which is B, since the gradient of a straight line is always the same. Then 1.3, a motorbike that's moving at a speed of V has kinetic energy, okay, which is E. If the speed of the motorbike increases to 4V, the kinetic energy will be, so from the formula of kinetic energy, EK is a half mv squared. That will be a half multiplied by m multiplied by 4, I'll say 4V, but squared. Now I simplify this, I'll have a half m times 16V squared. When we try to simplify, do we need to simplify that? Not really, not really, because I'm seeing a 16 there, so it would be like 16 multiplied by a half mv squared. So if EK or E was a half mv squared, which is this, so which means our overall energy is going to be 16 times. That is 1.3, and the answer is 16E. 1.4, consider the following statements concerning the ultraviolet radiation. Which of the following? No, it has a lower frequency than blue light. Okay, it has a longer wavelength than the gamma rays. It is radiated from the sun and may be harmful to humans. So lower frequency than blue light, no. Longer wavelength, that is true. Because yes, it has longer wavelength than the gamma rays. And then 3 is radiated from the sun, which is also true. So 2 and 3. Then 1.5, if we consider the diagram of two pulses A and B, I don't know, I found an issue with this question, whereby 1, we have the amplitude of A, but we don't have the amplitude of B. Let's read the question, maybe it will make sense. So if we have the following pulses, A and B as shown below, the amplitude is 25. In this case, we don't know the amplitude. Okay, when two pulses in the diagram overlap, okay, when they overlap at point X. So which means this A is moving to the right, this one is moving to the left. They're telling us that the resultant amplitude is a 40. Okay. The type of interference and the amplitude is the type of interference and the amplitude is. Now, since both of them are just in the same kind of direction, both of them are traps. So we expect the resultant wave or the resultant pulse to increase, okay? In other words, it should be bigger, which means it's going to be a constructive interference, okay? But because if this is a 25 with this amplitude and it's the biggest pulse, this is a shorter pulse, which is B. With a shorter, I'm having 15 and 15. I would have gone for A. I would have gone for A, which is like the destructive, since the directions are different. I mean, I'm moving in opposite directions. Okay, the arrows indicate that the directions are opposite. I'm going with option A. Can't be constructive, but doesn't make sense though, because when I say 15 and that's a 25, then given the 40, which means I'll have to go with B because of this 40. I'll go with B because they told me the resultant. So it means a constructive, but with that. All right, then 1.6, two identical spheres A and B are placed on insulated strands and they are carrying charges +2 microcoulombs and +6 microcoulomb respectively, okay? So when the spheres are brought into contact, dash electrons are transferred from which sphere to which sphere? Okay, so one thing we need to know is that when the two get into contact, we shall have a 2 + 6, we get 8, and then we divide by 2, which means each sphere will walk away with a +4 microcoulombs. Okay, so if that is true, how about if we calculate the number of electrons that would be transferred from N is equal to Q over E? So since this is a 4 microcoulomb, and we subtract the 2 microcoulombs, so which means there was a transfer of +2. Okay, I'll say 2 times 10 to the negative 6. I'm dividing it with a charge which is 1,6 times 10. Is it negative 11 or negative 19? Should be negative 19. Should be negative 19, yes, negative 6, negative 1,6 times 10 to the negative 19. Okay, so we're saying negative 19, not 11. So when I divide that, negative 6 over 1,6 times 10 to the negative 19. That's giving me 125 and a whole lot of numbers, zeros. So 1, 2, why should I look at that? I only have 1,25, this and that. I have option A and option D. Then I need to know, where will the electrons be moving from? Is it A to B or B to A? Okay, so in this case, this positive 6 is more positive than the positive 2, which means the electrons will be transferring from A up to B, so that they lower this positivity to just a 4. So I'll go with A. Then 1.7, 2 light bulbs, P and Q connected in parallel. You can see that the resistance of P is twice the resistance of Q. If this is just 1 ohm, this is gonna be like 2 ohms. If this is a 2, that will be a 4. Voltmeters V1 and V2 are connected across each. Which of the following statements will give the correct relationship of the voltmeter